Okay, this second part is a shortcut of what I just did on teaching you how to integrate by partial fractions. And this shortcut only applies to linear, non-repeating factors. So you cannot use this shortcut if you had repeating factors, repeating linear factors, or quadratic factor. This only applies to linear, non-repeating factors. And the reason I'm doing this is because on the AP test, you'll only be responsible for integrating by partial fractions for linear, non-repeating factors only. So the shortcut method will save you a lot of time. So rather than doing that expanded version out and solving a system of equations, whether you use substitution or linear combination, I'm going to show you the same problem, but we're going to do it using this shortcut method. So this was our original problem, and what we did, we started off by factoring out the denominator. So let me try that again for you and show you that we all recognize this is a trinomial, and it probably can be factored into the product of two binomials. So let's see, 3 and 2, and we just did this. This was a plus and this was a minus. So these are equivalent. And what we tried to do with partial fractions was think about what are two fractions that when added together would give me the original problem. This is what we started off with. So this is how the shortcut works, and you're going to really love this. You're going to ask yourself, you're going to look at one of these fractions, and you're going to say, for what value of x will make this denominator undefined? So when x is -2. So to find my a value, I'm going to let x equal -2. So I'm going to go to my original version right here, my original problem. And if I put -2 in here, you can see this is going to be undefined. But this is why I sometimes call this shortcut method the cover-up method. Because I'm going to do is, you have to watch this now. I'm going to take my finger and I'm going to cover up the factor that's below the letter A. So that factor has the x plus 2 in it. That's the factor that will make x equal -2 undefined. So if I cover that up, and wherever I see x now, I put -2, I'm going to have -2 plus 7 over -2 minus 3. And what do you get here? 5 over -5. This is -1. So A should be -1. And to find, you see that? To find B, we're going to let x equal, we'll go over to your factor that has the B in it, your fraction. Look below it and ask yourself, what value of x will make this denominator undefined when x is 3? So we're going to go to our original problem. And where I see that factor, I'm going to put my finger over it. I'm going to cover it up, cover that factor up. And to find B, I'm going to put 3 wherever I see x. And I get 10 over 5, or 2. So my bottom line is I have A will be -1 and B should be 2. And if we look back a moment ago, I did that problem for you. I think over here, let's see if I can slide that down. we had A was -1. Here it is. In this factor, A is -1 and B is 2. So I think you proceed integrate without having to use the linear combination method that I did. Let me slide it down a little bit more using the linear combination method back here. We don't have to do all of that. It's a lot quicker. So I'm going to leave you with a worksheet to do, and I hope you guys all have a good day and work together. Thank you. Hope to be back soon.